by 1. So it doesn't even really matter that we're talking about rings here. Just use the standard definition of how you would multiply things in whatever space you're talking about, and ask yourself if you can ever multiply two non-zero things to get 0. So the ring of complex numbers, oops. So this is not true, right? X, y equals 0 implies x equals 0 or y equals 0 if you're in the complex numbers, so that's wrong. B, integers mod 11. Again, 11 is a prime, so same thing holds. Option C is correct. Continuous real valued functions on 0, 1. So let's call this C 0, 1 to R. So the answer to this one, I can give an example. So let's take one function to be like this, and another function to be like this. These functions are both non-zero. You know, neither of these functions is the 0 function, so it is not the 0 element of the corresponding space, ring in this case. But if I multiply these two functions together, I clearly get 0. So this is the correct answer, but we can go on to the others. So the ring a plus b root 2, where a and b are rational, so the set of all possible numbers like this. You could work it out, take any two numbers of this form for different values of a and b, and you'll see that the product is never equal to 0 unless one of the numbers has both their corresponding a and b equal to 0. So that's not the right answer. And finally, option E, the ring of polynomials in X with real coefficients. Another pretty easy one to see, right? If I have P of X and Q of X, neither of which are the 0 polynomial. In particular, they must both be of degree non-zero constant or higher. Then P times Q of X there's the degree can only increase or stay the same. The maximum degree can only increase or stay the same. How else would I want to show this? I mean, well, maybe an easy way to see this, if this is identically 0, then this is 0 for all values of x. But if this is 0 for all values of x, then either P or Q must be 0 for all values of x. We can't have this situation here where it's 0 for some values and non-zero for others, such that they're product, because there's a finite number of roots for both of these. So when you multiply them together, you still have a finite number of roots. The only way you get an infinite number of roots is one of the original polynomials had an infinite number of roots. So that one's also wrong. Yeah, that's the answer, C. Good to have stuff like this in mind, where you can multiply things together and get 0. Nice little problem. Thanks for watching.